Uh, my name is Dr. M. Varadharaju, doing my postdoctorate in the Department of Production Engineering under the guidance of Dr. Ing Durai Selvam. And concerning to our subject, that is energy and environmental engineering, and we'll start from the basics. And this is what we are going to talk about the energy and environmental engineering. These are the syllabus which we have in our course plan, and see the present energy resource in India and different types of conventional power plants, and the scenario in India, and advantage and disadvantage of the conventional power plants, and the power generation over the conventional and non-conventional, and basics of solar energy, and solar thermal energy, photovoltaic, and its advantage and disadvantages. Similarly, we need to discuss about the wind turbine, and the energy potential, various energy potential, and its types, offshore wind energy, and the benefits and impacts. And similarly, we are going to discuss about the biomass resources and its various factors related to biomass, geothermal, and the pollution which affects the environmental, and greenhouse gases and its effects, and acid rain, noise pollution, and other pollution aspects related to the various power plant. And finally, we are going to discuss about the fossil fuels impacts, industrial and transport emissions, and its impact. And these are the friends. And once the syllabus is over, based on the this is what the outcome. And we'll start from the basic introduction. And what is the need to study? That was my first question. It is the forum is open to you all. You unmute your mic and tell me what is the need to do the education. What is the need to study? The purpose of education. You please unmute your mic and tell me. I think it would be a two-way communication. Then we have a better conversation, better communication, better understanding towards subject. For that, the two-way communication would be essential. And when you are attending the classes in person, that is a different scenario. And here we are unable to face in person, since we are in pandemic. We are unable to meet you in person, and by way of different modes, like MS Team or Google Meet, or different platforms, classroom platforms. And in order to have a better conversation, you please unmute your mic and please respond me, and that have a better understanding about the subject. And from the base, that is, what is the need to study? From that basic question, we will start our subject.
Sir, to get a proper knowledge in our environment, sir.
Very good.
About
1 point. One point. Okay, good.
The resources are always very important, no matter what time it takes. Like for different generations, different resources are needed based on the development. So we need to have an ideal environment so that it sustains for each and every generations that are to come. So environmental studies is really important for a sustainable development.
You are talking about the in particular. I am talking about general. Okay, very good, very good. What is the need to study? That was, then I'll ask the question about what is the need to do engineering, and then we will talk about the energy and environmental sciences.
Sir, to anticipate problems and work on that, sir.
Yes, 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 and
it helps to develop skills.
It develops skills. As Bhavya quoted, Bhavya, you come again with your answer, Bhavya. Yes, unmute your mic and tell me.
So to have a proper knowledge of this environment, sir, what is happening around us?
Okay.
And
As quoted by Bhavya and Nitish, and education is the only way get to acquire knowledge.
so to handle the society also, sir.
To have a
To handle the society also.
also. Okay, fine. Then my question is, education is the only way to acquire knowledge. Finally, we'll talk about the society and the benefits over the society. And quoted by Bhavya and Nitish, education is the only way to get knowledge or to acquire knowledge.
No, sir, because if you see it in the tribal regions and all of that, if you see, like a lot of them are not educated, but they know about how to take care of the environment better than like the so-called educated people, sir.
No. We regarding the environmental, we will adjoin later. Pranav, of course. And what are the other ways to acquire knowledge?
Sir, I would
But
say
science the
education.
experience.
One by one, one by one. Maitrein, yes, go ahead, Maitrein.
Sir, I would say education is just a platform for you to know better. It just like supports you. It pushes you to gain knowledge and skills as a support to material, sir. But there are like other resources through which you can also learn things.
What are the other resources? What are the other resources?
Sir, we can also
Uh,
learn from art, movies.
Yes, okay, art, movies, and then
that always self learning, and then
yes,
there are
self learning through.
self
Experiments.
learning through online
Through
platforms
our elders.
No, you
and experience.
we don't have any online platform. We don't have any group.
Self-learning to different practices.
Different
Practices.
practices.
We try out something. After then, we learn out of this.
Yes, very
There are
good. Absolutely, absolutely.
experiments.
Yes, Ankit. Yes, Ankit. Go ahead.
Yeah. So whenever we try on something, like we may even fail or pass, but we definitely learn out of it. So that is what we should keep on trying, doing something, and through which we learn. Through which we learn actually.
Yes, very good, very good. Like, yes, by doing experimentation, we can learn a lot. Of course, yes, as mentioned by Nitish and Ankit, yes, that is a very good way to learn everything, and in particular with engineering and science, and through by doing hands-on training, and we can learn a lot. And what Thomas Alva Edison did, Thomas Alva Edison has more than 1,000 patents, and he is very concerned about experimentation alone. And what he did, the 99 percentage of hard work is enough to invent a new thing, and that was the quote disseminated by Thomas Alva Edison. And think we are now we are trying to learn everything by doing hands-on training, not by doing education, not by doing or reading the books and text. And we are trying to learn. What happens when we will attain the present scenario or present status of the science? How long it will take? It is feasible to get acquire everything, every knowledge. See, let it be in particular to our department, area production engineering. In order to learn everything about production engineering, whether it might be a lathe machine or a milling machine or the machine which is handling on daily basis. For that, or whether it may be a tube light or a fan, to have a knowledge about these day-to-day activities, day-to-day science and technology inventions, we are doing experimentation and we are trying to learn. We are trying to learn. And what happens? How long it will take? Go ahead. The forum is open. Go ahead. Yes, unmute your mic and tell me. Yes, please unmute your mic and tell me.
So please repeat your question, sir, once again.
Someone please repeat the question. Someone please repeat the question. See, I'll repeat my question. See, you are trying to learn everything by hands-on training. How long it will take? In order to attain the present status of science, how long it will take?
Lot more than what we learn through theory.
Tell me in terms of years.
Decades.
Decades? No. It will take another it will take another 2000 years to learn everything. Not to attain the present state is not to get everything. We need to spend another 2000 years, and it won't be possible. That is what this need for the study. That is what the purpose of education. Not to know what all the things happened in the past. What was the present state is what we need to do. We need to take a step ahead, and not to take a step from the present step. What we need to do, we need to know where we are. That is what we are doing. That is what the purpose of education. That is the need for the doing education and all. And concerning engineering, you have spent 1 year. What you learned about engineering? What was the definition of engineering? And it is entirely different from science and arts and medical. And what was the unique feature, uniqueness of engineering? Anyone? My slides are visible? My slides are visible?
Yes, sir.
Yes, sir.
Yes. Okay, go ahead.
So engineering is about coming up with a solution to a problem.
Coming up with solution?
To a problem.
To the problems.
Yeah.
Very good. Very good. Very good.
Using technology to get a better standard of life.
Using technology to have a better
standard of life, like a better life.
Yes, better standard of life. Okay, not elevate the standards. Is we are depending the engineering and technology. Any other.
Sir, it gives a brief information what you have learned before the college days.
That is it might be the extension of the school education. That is what you are saying.
Yes.
Okay. Any other. Good. Any other. I think someone in the previous discussion itself, someone told about the mankind and benefits of human society. That is in that line, someone said.
Sir, engineer is a creator.
Okay.
Mostly based on practical studies, sir.
Yes, he will do practical studies. Okay, good. Any other? Yes, this is what we need. This is what the participation is very essential. Since it was a theory subject, what we are going to discuss about various theory, and I request you to put a separate notebook for this particular subject, and we are going to have we are going to disseminate various diagrammatic representation. You please note it down everything, and theory and all. You make key points, that is enough. And concerning the diagrams, you please make a note and have a separate notebook for this particular subject. And how our class has to be. What I usually plan, I'll make you to be very attentive, since we are going to discuss about subject. Along with the subject, not to deliver the subject alone to a person, a human is not essential. We have plenty of opportunity to learn the subjects. Even you give title by title in Google, it can disseminate every content, and even a single textbook is enough to have a better understanding about the subject. A person or a human teacher is not essential to disseminate a subject alone. In that way, we are going to discuss the many things. One might be the current affairs. Through current affairs, what we can learn, what is happening in and around us. That is what we will discuss, and we are going to disseminate puzzles and various informations, various interesting things we are going to discuss. And for that, I need your participation. Then only the class will be very interactive. Otherwise, I am sitting in front of one system and talking with the system alone might not be a right way. And for that, your participation is very essential. Okay, again, come back to the definition of engineering. Anyone have any other opinion about engineering?
Sir, engineering is the continuous learning or practice of different things by which we can make society's life better and better every day.
Yes, yes, yes. What is your name? What is your name?
Ankit.
Ankit. Very good, Ankit. Very good, very good. Fine, fine. Yes, that is what engineering. That is what engineering. And concerning what accreditation board for engineering technology, there is a board which is the authority for giving the NBA, the for the AICT giving National Board of Accreditation to the engineering colleges in India. The guidelines are derived or given by ABET, that was followed by AICT, and that is the Accreditation Board for Engineering Technology, usually called as ABET. ABET defines in a nice way, engineering is the profession in which a knowledge of mathematical and natural science gained by study, experience, and practice is applied with judgment to develop ways to utilize economically the material force of nature for the benefit of mankind. The everything should be happen for the benefit of mankind. That is what the key point
तो उसका नेटवर्क इशू है क्या?
Yes, now check with audio. Now it is audible.
Yeah.
Yes, sir.
Yes. Yes, sorry for the interruption. There is a net issue. Sorry for the interruption. And that is what about engineering. What we need to do, we need to always conscious about the betterment of human society. That is the main quote. And we know what happened in Hiroshima and Nagasaki, and that was the major accident which was made by the human invention, and that should not be repeated again and again. For that, we should be very cautious about the betterment of human society. That is the key point. That is very essential and very important thing. And wait just a minute, I'll yes. See, and now we'll talk about energy and what is energy, why we need energy, and from your point, what is energy? My slides are visible. Go ahead with the definition of energy. What is energy?
Capacity for
Energy.
doing work.
Yes, very good. Capacity for doing work. That is energy. That's it. That's it. Any other definition? Any other definition? Okay. I'll tell you. The thermodynamics can be defined as in science of energy. From that thermodynamics, we need to start energy. Have you come across the subject called thermodynamics? Have you studied thermodynamics in the past?
Sir, in 12th grade.
12th, not in 12th, in the engineering syllabus. Have you crossed the subject
sir.
thermodynamics?
No,
No.
Sir, we did not cross.
Thermal engineering, thermal science.
No, sir.
No, I think it will be. And for thermodynamics can be defined as science of energy. Energy, as I said earlier, the energy can be viewed as the ability to cause changes. Energy means capacity for doing work. That is what the energy, and which is derived from the Greek word energia. And thermodynamics also derived from the Greek, and thermo means heat and dynamics means power. And through that we need to start our subject energy, and we have three different parts that might be divided into two, even two: energy and environmental. From where once the energy is over, we'll talk about the environmental and environmental science, from where we need to start the environmental, at what time the government has the conscious over the environmental, and at what time government forced the institution to have a subject titled environmental engineering, and that will disseminate one by one. Concerning the energy, we need to start from the principle of conservation of energy. Yes, wait. We'll talk about environmental engineering little later, and thermodynamics. I have stated about thermodynamics and concerning the principle of conservation of energy, and these are the things already you studied during even school days. Anyway, I'll refresh those contents. That is one of the most fundamental law of nature is conservation of energy principle, and it simply states that during an interaction, energy can change from one form to another, but the total amount of energy always remains constant. That is, energy cannot be created or destroyed. And concerning the first law, and the first law of thermodynamics simply an expression of conservation of energy, and it states that energy is a thermodynamic property. And concerning the second law of thermodynamics states that energy has both quality and quantity. And what happens in first law? The first law states it is a thermodynamic property, and in second law it states that about it has both quality and quantity. The actual process occurs in the direction of decreasing quality of energy. That is what about the second law, and we need to view these first law and second law with the aid of the various examples. And the water is flowing from an overhead tank through a pipe, which might be an example. That is, potential energy is converted into kinetic energy, and a rock falling off a hill picks up speed as its potential energy is converted to kinetic energy. And like that, we have various examples to understand about these principle of conservation of energy. And concerning the second law, a cup of hot coffee left on the table eventually cools, isn't it? And what happens? The high temperature and energy of the coffee is degraded. That is transformed into a less useful form at a lower temperature. And once it is transformed to surrounding air, and that a cup of cool coffee in the same room never gets hot by itself, isn't it? Isn't it? That is what the second law of thermodynamics. And the irreversible process in thermal system, that is the entropy, that we will discuss a little later when there is a need to talk about it. At that time we will reveal about the reversible process, that is entropy, and the renewable energy versus non-renewable energy. Even in your school days, you may concentrated, or you may spend more time with respect to these titles in order to give a presentation, or in order to give a project, or it might be a mini project, because the already government taken the initiative towards these renewable and non-renewable energy. And I think you are already aware about these terms. And energy, the renewable energy, which is produced continuously in nature, and it is neither consumed nor converted into something else. And concerning the non-renewable energy, which has been
Sir, you are not audible, sir.
yes, 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 yes. Now check. Now check the audio. Now it is good.
Yes,
Yes,
sir.
sir. Yes. Now it's audible, sir.
Yes.
Yes, sir. Thank you, sir.
Yes. Yes, from the tomorrow's class, we'll request 10 people to join with us till the end, because what is happening behind screen, I don't know. Therefore, we'll, for concerning the current today's class, we'll request 10 people to join with us till the end. To you unmute your mic and please join with us till the end. And I'll read the name. And from number 2, roll number 2, 4, 6, 8, 12, 14, 16, 18, 20, 22. You please unmute your mic and please join with us till the end. Akash, Abhinav, Amin, Ankit, until I think my Excel is also populating to you all. You please unmute your mic and please join with us till the end. Yes, unmute your mic. Ankit. Yes, please join with us. If your environmental is very poor, then you can move. Akash, yes, please join with us till the end. Akash and Kit.
Yes, sir.
Yes. Akshay Tomar.
Yes, sir.
I mean, yes, yes. You please unmute. Till 22. Till 22, you please unmute.
Yeah, sir.
Yes, yes. Yes, this is what the source of energy and the renewable energy sources. The
So you are not audible.
Sir, you are not audible, sir.
Now check the audio.
Your voice is breaking, sir.
My voice is.
Breaking.
Yeah, it's fine, sir. No.
Sir, not clear, sir.
Yes, yes. The renewable source of energy further classified into hydel, solar, wind, tidal, and geothermal biomass. And concerning the non-renewable, we have fossil fuel, fossils, and nuclear. And concerning fossil fuel, we have solid, liquid, and gaseous states. In 3 different states we have. And this is what the starting point of the our syllabus, that is present energy resource in India and its sustainability. And we have the energy department in our India. With that itself, we have a number of data. And concerning energy, I have already talked about energy. It is considered as basic input for a country, and our existence is mainly depends upon the energy. And energy exists in various forms and is used for producing power. And concerning the electrical power being versatile, is used for producing power. Different forms of energy available is converted into electrical energy. That was the main sources of the each and every country. And see here, there are some picture is also represented. We have biomass, solar, water, wind, and geothermal. And what we need to think here, see, the energy is the ability to cause changes, and matter that stores energy is called fuel. And energy can be generated from fuel, whether it might be a coal or petroleum or natural gas. And in order to produce powers, we are utilizing these sources or these fuels. And sustainable energy is the practice of using energy is a way what meets the needs of the present without compromising the ability future generation to meet their own needs. And that is what about sustainable energy. And some basic units we need to remember anyway. You please look into it. And once we are trying to solve some minor problems, at that time we need to be very conscious about these units, the unit conversion and all. Anyway, at this time, you please have a visit over this energy unit, that is foot pound force British thermal unit, and that is what usually called as BTU, horsepower hour, and gasoline gallon equivalent, and kilowatt hour, and megajoule, and the electrovolts, and some other units, and its unit conversion, calories, and the calories conversion. 1 calorie 4.1868 joule, and 1 kilowatt hour, and BTU, as I already talked about BTU, and some other barrels. We are talking about barrels and all, and the price rise in barrels directly impacting on the price rise in the petrol or diesel, or when it might be crude oil, and 1 ton oil equivalent to 1 tow, that is barrel of oil, and that we need to convert into liters, that I'll tell you about liters. And anyone aware about 1 barrel equal to how many liters? 1 barrel is equal to how many liters? No, I think what happened? Okay, this is what these some energy.
Approximately 120 liters.
120?
Liters.
123. Okay, today Google it, and tomorrow we will inquire about 1 liter. And this is what the under solid fuels we have various solid fuel like the lignite and all. And concerning the gases, and coal gas, blast furnace gas, producer gas, and coke oven gas, this is what we are going to talk about. And with this the energy basic energy units, and see, this is what is the energy resources and classification of energy resources, and based on the energy storage and cycling, it can be classified into renewable and non-renewable, and based on the transaction, it might be commercial, non-commercial, based on the consumption, and depletable and non-depletable. This is what the major concern about the today's scenario, and it was even started before 3 to 4 decades itself. We are concentrating about we are worried about the non-depletable and depletable. We are concerned about these things. And see, when we are concerning about the regularity, it is classified into conventional, non-conventional, and conversion, primary and secondary. And concerning this primary, we have chemical, potential, kinetic, and radiation heat nuclear. And concerning the secondary conversion energy source, we have electricity, mechanical energy, and chemical energy. And in chemical, here chemical we have fossil fuel and biomass. Under fossil fuel, we are going to utilize about the coal, oil, natural gas, and peat. And biomass, we have wood, agricultural residuals, and etc. And we are the potentials, we are going to use the potential of the dams, waters, and kinetic. We are going to use the wind and tidal powers, and radiation. We are going to learn about the solar power, and heat, the geothermal reservoirs, and ocean thermal reservoirs. We will talk about it. And concerning the uranium, thorium, and all comes under nuclear power plant. And this is what the various classification of the energy sources, and this is what we are going to talk about. This is where we are going to start our subject, energy, and little later we are going to talk about the environmental science, or the some typical picture related to energy and non-renewable energy. And see here, hydropower energy, solar, biomass, wind energy, and geothermal. And concerning the non-renewable, we have the fossil fuels, coal, and natural gas, and nuclear. And what we need to do, we need to make use of the renewable, and we need to increase the percentage of utilization of generation and utilization of renewable energy because it is non-depletable in nature. And concerning the non-renewable, we need to worry about the availability. We need to conscious about the utilization of future generation, and even in order to reduce the pollution and other environmental factors, we need to worry about it, and we need to have a look into the reduction of utilization of non-renewable energy. And see, the energy consumption by source of 2018 US states about what happens here. The petroleum products are the percentage of utilization of petroleum products are 36.5, and concerning the natural gases 30.6, and coal 13.1, and nuclear power is 1.6. And what happens, they are having a long-term plan, and they have started to convert this non-renewable utilization of non-renewable energy percentage. They are trying to reduce this percentage, and they are trying to increase the percentage of renewable energy. And concerning the biomass, they are having 5.1 percentage, and hydropower 2.7. See here, this is what the major difference in India, and we are using very larger hydropower we are producing and we are utilizing. And here the numbers are talked about in BTU, and the British thermal unit, and concerning the world energy consumption. And what we are thinking, we are utilizing the oil in a longer way, but it might not be. And we are for automobiles we are using oils, and that is also in the past budget. Central government budget, they are converted into they are encouraged the usage, the development of the non-renewable energy sources, and they are enforcing us to build and generate the automobiles, which is the electrical vehicles. They are advising us to convert the usage of fuel into, and they are wanted us to make electrical vehicles. And see here, the percentage of oil is very minimal, and here it is this is what the percentage, and here also it is very minimal. And here see here the percentage in African countries, and Latin America also. And concerning North America, it is too minimal. We are going to find any oil, and it might be very minimal. And concerning Europe and other countries, also that is very minimal. See China is using 214, and rest 114 BTU, 115, and 149 BTU. And this is what the percentage of coal and gas is very huge in all the countries. And concerning the distribution power, see here the percentage of distribution power is 1/4 greater than in North America. Similarly, it is greater in Europe and other countries. And China also utilizing the distribution and the quarter of amount in the energy consumption. And we need to critically review these charts, and anyway we'll talk about one by one. And concerning this, what the data which is derived, which is got through the Ministry of Power, and it was taken, see here, it was taken as on 14/3/2021. And the central power capacity is 25.4 percentage concerning state, and 27.5 percentage the private sectors having major power sources, that is 47.3 percentage. And that is what the major issue in India. And anyway, we'll talk politics little later. And concerning the coal, we are using 53 percentage. Concerning the lignite 1.7, gas 6.6, diesel 0.1. And see here, I have already talked about the hydropower, and we are using 12.2 percentage of hydroelectric power plant. And RES, that was the major percentage in percentage, that is 24.7, and that is renewable energy source, which includes the hydropower hydro projects, biomass, and urban industrial waste power, and solar and wind energy. And this is some other typical example, the performance generation from conventional source, and around 10 to 12-year data were given. And see here, in the last 2 years, what happened in 2019-20, usually it is about 5% of growth we have every year, and concerning last 2 years it went into 0.95, and concerning the present year it is too minimal, and even it went to minus 0.2, minus 2.49. Yes, it is audible. It is audible, Akash.
Yes, sir.
Akash, it is audible, Akash.
Yes, sir. Yes.
Akash, it is audible.
Yes, sir. It's audible. 1 second.
Yes, yes. And we have some other data also. Anyway, we'll discuss about these data, and what we need to think. We need to think about the environmental constraints. Yes. What happened? There are non anthropogenic impact of on environmental happened in the last few years, and the major instance and major disasters or what we need to think, and we need to learn from the various disasters. And see here, there are major incidents happen in the last few years. In what happened in 1992, so there is a huge cyclone happened in AP, Andhra Pradesh, Tamil Nadu, and Pondicherry. Around 1,400 people lost their life during that cyclone, and around 39 billion public property lost during that cyclone. What happened in flood during 93 flood? 12 states affected during that floods, and 1,600 people affected a lot. And during earthquake in 1991 and in 1993, Tamil Nadu, Kerala, and Pondicherry affected a lot, and around 8,000 people lost their life, and 4 billion public property lost during that disaster. And see here in 2004, what happened? Tsunami happened in Tamil Nadu and Pondicherry. Around 15 million people affected, and 20,000 human life lost during that disaster. And what happened? It is true to admit that the process of development bears a direct influence over the environment. It has been discussed. Several man-made activities development progress not only cause the environmental degradation, but also results in rapid depletion of natural resource. The poverty and pollution explosion in developing countries involves economic implication, have an adverse effect on countries that involves economical implication, have an and the sustainable development aimed at improving the basic needs for human society is not directed to produce any harmful impact on an environment. And both the environmental stability and development progress are the two important facts in human society which remain interlinked with each other. And any development progress could be considered to be the positive growth oriented one, and when it does not interfere with the present status and trend of the environmental. That is what the environmental science made an attention. And and the acid rain ozone depletion and global warming, making us to make attention towards the environmental science and studies. Yes, go ahead. What happened? There are two different authorities, that is World Meteorological Organization and Global Environmental Monitoring Systems, are giving various information related to these environmental happenings. That is what we are going to talk one by one. And there are two authorities I am repeating: World, that is WMO, World Meteorological Organization. The other one is Global Environmental Monitoring System. With this two organization information, we'll talk about the principles of environmental science, and we'll talk one by one. And see this the plant load factor. What happened here? The PLF reduced year by year, 77 into 75, 73, and now in 2021, and it is 53.37. The power supply position from 910 to 2021. See here the surplus and deficit. And what happened? We don't have any surplus energy. There is a deficit, and see here in 2021 we have deficit of 0.4 percentage, and in this is what even we have a long-term plan for developing power. Even at the peak loads also we are having difficulties now to give proper power. There is no need to have conscious about the surplus. What we need to do, we need to give a power, but here we have a deficit over the energy production. And what we need to concentrate, we need to decrease this deficit. And the billion units, the total generation including the renewable source of energy. And during 1819 it is 1376, and concerning 1920 it is elevated to 1389. And the percentage rate, and see here the percentage rate is decreasing and then increasing. There is a drop and then increase. See here, 5.69 to 5.8, there is a decrease. And during 14-15 it was 8.84, and 11-12 it is 9.14. And concerning the last year 1920 it is only 0.995 percentage. And plan wise growth, and these data we will talk one by one. And do you want to discuss anything apart from do you have any doubts with the present presentation? Do you want to share anything? Do you have any doubts with the presentation?
No, sir. Thank you, sir.
Okay, tomorrow we'll meet during 10:30 we'll meet. If you don't have any doubts, tomorrow morning 10:30 we'll meet. Thank you.
Thank you, sir.
Thank you.